So this is the core pure 1, chapter 9 vectors, mixed exercise 9. So we start with number 4. Straight line has vector equation, which means it has x equals 3 plus 2 lambda, y equals negative 2 plus lambda, z equals 1 minus lambda. So when we arrange them all in the subject of lambda, then x minus 3 over 2 equals y plus 2 equals z minus 1 and minus, like this. So this is all of them lambda, so we can put them all together because they are equal. So this is the Cartesian equation for the line L. And given 0, A, B lies on L, value of A and B. So when x equals 0, lambda equals negative 3 over 2. So then y becomes negative 3.5, z equals 2.5. So this is B, A, and this is B. And number 9, the origin position vector, we have 3 vectors and vectors ML, MN. So we want to express MN, ML. So MN, ML vector is L minus M. So L minus M, 3, 4, 5. N vector is N minus M, 1, 1, 4. So we can prove the cosine vector, cosine with the dot product. So cos L M N becomes ML dot MN and ML magnitude Mn magnitude. So dot product is 3 times 1, 4 times 1, 5 times 4. And the lower part is 3 squared, 4 squared, 5 squared, which is 50. 1 squared, 1 squared, 4 squared, which is 18. So 27. 50 times 2 times 9, which is 110, and 3, 30, 27 over 30. Therefore, 9 over 10. Number 10, refer to fixed point of origin, ABC, position vector like this. PQ are constant in vector form equation of line passes through A and B. So R equal A, 9, negative 2, 1, plus lambda, AB. So negative 3, B minus A, 4, 5. This is L. So given C lies on L, value of P and Q. When x equals 3, lambda is 2. Then x equals 3, y equals 6, z equals 10, 11. So P is 6, Q is 11. In degree, acute angle between OC and AB. So OC and AB, let's call it cos theta with OC dot, OC dot AB and OC magnitude, AB magnitude. OC, now we know 3, 6, 1, and AB, we know negative 3, 4, 5. So 3, 6, 1 dot negative 3, 4, 5. So negative 9, 24, 5, which is 20. And OC magnitude is 9, 36, 1, 46, and 9, 50. Square root 50 times 46. Therefore, theta becomes arc cosine 20 over square root 50 times 46. 65.4 degree. Point D lies on AB, and OD is perpendicular to AB. A, B, D, for example, like this. So position vector of D. So, okay, OD. So D vector, we can express it because it, since it is on AB, I mean the line L, so 9 minus 3 lambda, negative 2 plus 4 lambda, 1 plus 5 lambda. This is OD. So when it's perpendicular, OD dot AB equals 9 minus 3 lambda, negative 2 plus 4 lambda, 1 plus 5 lambda, dot. Now we know what is AB, negative 3, 4, 5. Should be 0 because it's perpendicular. Perpendicular means cos theta, cos 90 degree, cos pi over 2 becomes 0. So negative 27 plus 9 lambda minus 8 plus 16 lambda plus 5 plus 25 lambda equals 0. 50 lambda becomes 35, 30. So lambda is 0.6. So position vector of D becomes 0.6, 1.8, 7.2, 0.4, 4, like this. And number 20. Pi 1 and pi 2 have equation, and the position lies in pi 2. Okay, 2, negative 2, 3, dot 2, negative 1, 1. Should be 0 to prove this point is in pi 2. So 4 plus 2 plus 3. Oops. Pi 2, sorry. So 1, 5, 3. So 2 minus 10, 9. 1, 5, 3. So it should be 1. Okay, therefore A lies in pi 2. Pi 1 is perpendicular, pi 2. So the normal vector 2, negative 1, 1, dot 1, 5, 3 becomes 2, negative 5 plus 3 equals 0. Therefore, pi 1 perpendicular to pi 2. The first one, the pi 1 like this, and the normal vector which is perpendicular to the plane is 2, negative 1, 1. Pi 2 also has this, like this normal vector with 1, 5, 3. So find the vertex form, vector form equation of straight line through A perpendicular to pi 1. So we already know the perpendicular vector on pi 1, which is 2, negative 1 plus 1. So R equals through A 2, negative 2, 3 plus lambda 2, negative 1, 1. So number D, the coordinate of the point where this line meets pi 1. So x equals 2 plus 2 lambda, negative 2 minus lambda, 3 plus lambda, dot 2, negative 1, 1 should be 0 to be on pi 1. So 4 plus 4 lambda plus 2 plus lambda plus 3 plus lambda becomes 0. So 6 lambda becomes -9, lambda is -3/2. So the coordinate of the point, which is this one, but this is position vector, but we can find the coordinate. So -2/3, which is -1, comma, -0.5, comma, 1.5. So when the question asks you about the coordinate, you need to write it like a horizontally coordinate form. But if it asks you about the position vector, then you can write it as a vector form. So find the perpendicular distance of A from pi 1. So now we have like pi 1 is here and A was here, and now we found this line equation which from C. So just now we found the coordinate here, -1, -0.5, 1.5. So if we call this P, let's say, then the perpendicular distance A from pi 1 is the length of AP, magnitude. So P minus A. So this is P, and this is A. P minus A. -3I plus 1.5 J minus 1.5 K. Just to make the calculation easier, let me take out 1.5. -2I plus J minus K. So 1.5 square root 4, 5, 6, 6. This is the shortest distance, perpendicular distance. Number 21. We have two lines, L1, L2, line intersect. Okay, so 1 plus, actually 2, 1, -2 is not parallel to -3, 0, 1, therefore intersect. Two lines are not parallel or coincide, therefore lines intersect. Number B. Yeah, actually I don't need to explain this one, coincide, because coincide maybe it also intersect, but at like infinite solution. This is one solution I just explained. No parallel, then eventually it meets as some, no, sorry. Just now my explanation was based on the 2D, but now we are on 3D. So sometimes when they are not parallel, still they can be the skew. So let's make it like this. So x 1 plus 2 lambda becomes 1 minus 3 mu. 1 plus lambda becomes 2. -2 lambda becomes 2 plus mu. So lambda is 1. When lambda is 1, mu is -4. So we can tell just now I used the second and third equation. So I need to verify this one. 1 plus 2 becomes 1 plus 12. Oh, am I right? One plus lambda equals 2. 1 plus 2 lambda equals 1 minus 3. They don't meet. Actually, they don't meet because when lambda equals 1, y is same. Y coordinate is same. And z mu equals -4. Y and z are same. But in this case, x is not same. So they don't intersect. Number B, position vector, their point of intersection. Oh no, they don't meet. Maybe if I didn't make any mistakes, maybe there is some typo for the question or something like that. Number C, cosine of acute angle between the lines. This is about the direction vectors, angle between direction vectors. So cos theta becomes 2, 1, negative 2, dot negative 3, 0, 1, square root of 2, 1, 2, 3, 0, 1. So square root of 9, square root of 10, negative 6, 0, negative 2. So negative 8 over square root of 90. Therefore, theta becomes negative 8 over square root 90, which is obtuse angle since cos has negative value 147.49 degree, but the answer should be acute angle because the two line has like this. Just now we found this angle, but we can't find this angle because those are just supplementary. So 180 minus answer makes it 32.5 degree. Number 22. Lionel has vector equation like this and scalar parameter. Point A has coordinate like this. Point B coordinate like this. AB lies on the line L1. Okay, so lambda is negative 3 in this case. So A becomes 11. B becomes lambda is 2. So 7. So given point O is the origin, point P lies on L1, OP. So this is L1. P here, O is here, and OP is perpendicular to L1. Find the coordinate of P. So P is just the OP is 6 plus lambda. Let me just make it like a direction vector dot OP. 6 plus lambda, 8 minus lambda, 5 plus lambda dot direction vector 1 minus 1, 1 should be 0 because it's perpendicular. 6 plus lambda minus 8 plus lambda plus 5 plus lambda becomes 0. 3 lambda, 3. Lambda becomes negative 1. So when lambda equals negative 1, the P equals 7, no 5, comma 9, comma 4. Find the distance OP. Giving your answers in third form. It's just the magnitude of this OP vector. 5 squared, 9 squared, 4 squared. So 5 squared, 9 squared, 4 squared. 122 square root. Number 23. Relative to a fixed point P. Point A position vector, point B position vector. Linear path through point A and B. Vector AB, B minus A. So B minus A, 5 minus 6, 2 minus 3, 6 minus 4. So vector equation for the line L. So R equal 6, 3, 4 plus lambda, negative 1, and 2. Point C has position vector 4, 10, 2. Point P lies on L. Given CP perpendicular to L. Okay, so P lies on L. This is C and this is P. L. So P is 3 minus lambda. 6 minus lambda, 3 minus lambda, 4 plus 2 lambda. C is 4, 10, 2. So CP is P minus C. CP dot direction vector should be 0 because it's perpendicular. So CP, P minus C. 6 minus lambda minus 4, which is 2 minus lambda. 3 minus lambda minus 10, negative 7 minus lambda. 4 plus 2 lambda minus 2. So 2 plus 2 lambda dot direction vector of negative 1, 2 should be 0. So 2 plus lambda plus 7 plus lambda plus 4 plus 4 lambda becomes 0. 6 lambda becomes negative 9. Lambda equals negative 3 over 2. So point P is 6 minus lambda. So 7.5. Position vector. Okay, so I need to answer with the vector. So 7.5i plus 4.5j plus k. This is P. Number 24. We have L1 and L2 meets and find the position vector of their point intersection A. Okay, so let's put them together. 3 plus 2 lambda becomes 1 plus mu. Negative 2 plus lambda becomes 12 minus 2 mu. 4 minus lambda, 8 minus mu. So, whatever it is, just let me make it like this. So when I add them together, 2, 20 minus 3 mu. So mu is 6. When mu is 6 here, this is 2, lambda is 2. So this is the solution just to make y and z together, like equal. So we need to check the x too. So 3 plus 4 equals 1 plus 6, which is true. Therefore, they meet and the position vector intersect A because when lambda equals 2, so 7i plus 0 plus 2k. So this is the A. And B, nearest 0.1, the acute angle between L1 and L2. So cos theta becomes 2, 1, minus 1, dot 1, 2, negative 1. And magnitude the same, 4, 1, 1. So 2, negative 2, 1. 1 over 6. Therefore, theta becomes arc 1 over 6, 80.4 degree. And number C. Point B has position vector 5, negative 1, and 3. Show that B lies on L1. When lambda equals to R becomes 1. R becomes 5, negative 1, and 3, which is OB. Therefore, B lies on L1. Shortest distance from B to L2. So B is here. So they meet like this. This is L1 and this is L2. Now we know the angle between L1 and L2, which is 80.4. And what do we know again? The intersection point here, which is A, 7, 0, 2. Shortest distance from B to L2, like this. So since we know B coordinate is 5, negative 1, 3. So AB vector magnitude is B minus A, negative 2, negative 1, 1, which is 6, square root 6. Therefore, the distance, this one, let's call it H, becomes AB magnitude cos 80.4. So AB is square root 6, cos 80.4 is 1 over 6, which we found, 1 over 6. Therefore, square root 6 over 6. This is the shortest distance, but it asks us to find the 3 significant figure. So 0.408. This is the answer. Number 25. Plane P has an equation like this. L passes through the point A and meets for 2, -1. So this is the plane P, and it has the equation. The line is like this, and this is P, 4, 2, -1. This is A, which is 1, 2, 2. Acute angle between plane and the line is alpha. So let's call here alpha. And find alpha to the nearest degree. Okay, so now we know the normal vector and the direction vector. We will know the direction vector. So the normal vector is 2, -2, and 3. So cos alpha, no, actually not cos alpha, because now we will find angle here, the between normal and the direction vector. So cos 90 minus alpha becomes 1, let's make it PA. So A minus P, A minus P, A minus P, 3 dot n normal vector 2, -2, and 3, and square root 3, square root 2, square root 4, 4, 9, 17. So this one -6 and 6, 9, which is 3. So 1 over square root 34. So arc cos 1 over square root 34 is 90 minus alpha. Therefore, alpha is 90 minus answer, which is 9.87 degree. So perpendicular distance from A to plane P. So now we already know 9.87 degree. So and P and Q. So again, if we call this H, becomes PA cos magnitude cos alpha. PA, did I find PA? Was it this one? Yep. So 3 square root 2 is the magnitude, which I found. And cos 9.87 degree is cos, no, this is not cos, sorry, this is a sine. So sine answer times 3 square root 2. So 0.728. Number 26. Two airplane has molded as traveling straight line. A position vector. So R equals -120, -80, 13 plus T. Oh, no. This is the departure and arrival. B also departure and but it has a direction. Show that flight paths of two aeroplane will intersect, like a path intersect, and determine the position vector of the point of intersection. Okay, so R, A, this is just a path. So 120, -80, 13 plus T, TA, let me call it TA. So we start from A to B. So direction is A to B. So AB vector. So B minus A, B minus A, P minus A. Like this. And this one, B is start from -20, 35, 5, plus TB, this is not time yet, 10, -2, 0.1. So we need to find the intersection point. 120 plus 80 TA can be negative 20 plus 10 TB. So 12 plus 80A becomes negative 2 plus TB. And negative 80 plus 100 TA becomes 35 negative 2 TB. So 100 TA negative 2 TB. And the last one, 13. Let me make it 130. Negative 80 becomes 50 plus TB. So this is the one. So we need to show that they meet together. So this one, again, 8 TA minus TB becomes negative 14. And 50 TA plus TB becomes 110 157.5. And TA plus TB becomes 80. So we can make it with second and third one. So 30 TA becomes 22.5. Right? So TA becomes 22.5 over 30. So 0.75 from here. And if I make it this one, then TB becomes 20. So this one, I need to verify it for the first question. So 8 times 0.75 minus 20. 8 times 0.75 minus 20 becomes negative 14, which is true. So they meet together when TA is 0.75 and TB equals 20. So the position vector for the point of intersection is when TB is 20. So this is like a 20 here. Let's say 200. So 180. I negative 40, negative 5J. And 22 and 5, 7. So this is the position vector of the point of intersection. And number B, traffic controller state that means the plane will collide. Explain why this conclusion is not necessarily correct, because at this moment actually we don't know the velocity vector. So there is no clue for the velocity vectors of two aeroplanes. Thus, they may or may not collide according to their velocity. So not necessarily correct.